Hello everyone. Now we'll go to the next problem in the projection of solids series. Here we have a square pyramid 35 sides of base and 60 axis length rests on HP on one of its edges of the base. Draw the projections of the pyramid when the axis is inclined to HP at 45 degrees and to VP at 30 degrees. So let us look at the criteria which we are supposed to satisfy to get the solution to the problem. The first criteria is the shape, a square pyramid. Second criteria is the dimension, that is 35 sides of base and 60 axis length. Third criteria is it is resting on HP. Fourth criteria is resting on one of its edges of the base on HP. Fifth criteria being the axis is inclined to HP at 45 degrees, and sixth criteria being the axis is inclined to VP at 30 degrees. So we have 6 criteria which we are supposed to satisfy. So let us go to the solution to the problem. The first step is to draw the reference line or the XY line, right? So I have X, Y, VP and HP, right? So we have a square pyramid of 35 sides of base and 60 axis length. So let me draw a square pyramid over here of 35 sides of base. So again 35 and close it, right? So I have all the square. Now to identify the axis point O bracket O1, I shall draw two diagonals. So we do not have A bracket A1 over here, we just have the base. So I'll start off with one point. So I have my point A, B, C and D, and I have my point O bracket O1. O bracket O1 is the one and only line, vertical axis line, which has got O bracket O1. So others we have just A, B, C, D, which is the base corners. The next thing that you must know with respect to pyramids is, from the axis point to all the corners, whether it's a square, pentagon or hexagon, you must draw a visible line. So here to all the four corners, that is a square, so O to A, O to B, O to C and O to D should be visible line. So this is basically we are trying to draw the top view of the inclined edges, right? Now next I shall draw the dimension. So I have a dimension of square 35 okay. Draw the projection lines over here and let us get the front view for this. So I'll draw the projection line. B and C will be in the same straight line and A and D will be in a same straight line, and O bracket O1 will be here, and it is the axis which makes an angle of axis of 60 length. So from here I shall draw a 60 line, axis line. So this becomes my point O, this becomes my point O1. From the vertex, from the point O, I shall join this with a proper visible line. So in the front view, the square pyramid looks like a triangle. And here I have B dash bracket C dash, and this I have A dash bracket D dash, right? And the dimensions I shall provide now. So this is going to be 60 mm. Right? So everything with respect to the first position, front view and top view is completed. So we have a square pyramid of base size 35 mm and axis length 60 mm, resting on resting on HP and one of its edges of the base. So that edge resting on one of its edges of the base, that will satisfy the second position, but we are preparing for it in the first position itself, right? So in the second position, I have to satisfy the criteria that it is resting on one of its base edges, right? So base edges, according to my figure, it is going to be either B dash bracket C dash or A dash bracket D dash. One of these two I can rotate it. So my triangle, I can either rotate it in the clockwise direction or in the anti-clockwise direction, because both the sides I have edges only, that is B dash bracket C dash or A dash bracket D dash. So I will rotate with respect to B dash bracket C dash, but not with respect to A dash bracket D dash, right? So what I will be doing here, I will be locating a point here. I shall call that as my B dash bracket C dash. Now, unlike the prism problems, the edges were parallel to the axis line. So directly I drew the edges, but here the edges are not parallel to the axis line. So what we'll be doing is, we'll be instead drawing the base first. That is B dash bracket C dash to A dash bracket D dash. This base line we will be drawing first. So but at what angle we will be drawing? That angle is, let us assume it as some theta value, which is equal to 90 minus the angle provided in the question. The angle provided to me in the question is 45 degrees. So again, so 90 minus 45 is 45 degrees. So I will be drawing in the reverse direction. That is, from this side I will be drawing 45 degrees, locating 45 degrees. I will be drawing a line here. Using a compass, I shall measure from B dash bracket C dash to A dash bracket D dash. Measure that length, keep it here and cut the arc, and I shall get the line, get the point A dash bracket D dash. Now, after doing that, I'll measure the distance. I'll measure the distance from B dash bracket C dash to O dash. I'll measure this distance, keeping it here. I'll cut the arc. The same distance is from A dash bracket D dash to O dash. So keeping it here, I shall cut the arc. So this becomes my point O dash, right? So now I have recreated this particular second position front view. And the same time, locating the point O1 dash, I'll measure this distance. I shall cut the arc here. I have gotten my point O1 dash. I shall draw the and I'll extrapolate this line backwards. Now, if you actually measure using your protractor, you will observe that this angle is at an angle. This axis is at an angle of 45 degrees. So this is the reason why I took 45 degrees here based on this particular equation. And this becomes 90. So that is how I get this 45. So for example, if the question states that the axis is inclined to HP at 30 degrees. So then we will be taking theta as 90 minus 30. So that becomes 60. So we will be starting off with 60 degrees over here. Then automatically this angle becomes 30 degrees. So whatever angle is provided, 90 minus that angle will give you the theta value, that which you can take it from here. Okay, so when we go to the next problem where the angle is other than 45 degrees, you will understand better. Okay, so from this point, let us draw the projection lines. So from B dash bracket C dash, I shall draw one projection line. From A dash bracket D dash also, I'll draw one projection line, and from O dash I shall draw one projection line. A, B, C, D from the first position top view I shall draw projection lines, and from here also I'll draw the projection line. So please try to understand the point O dash is a real line in case of pyramids. Okay, so we will have to locate the point O dash continuously. Unlike in case of prisms, we could do that in the last, but in case of pyramids, we will have to do it along with the entire solid itself. So now let us locate the points now. So I have my point A over here, B, C, D, and my point O. Now apply the rules as similarly what we did in case of prism problems. So A to B, B to C, A to B, B to O, sorry, A to B, B to O, O to C, C to D, and D back to A. Next, identify the point closest to the XY line or overlapping points closest to the XY line or touching the XY line. So in this case it is B dash bracket C dash. So my B dash bracket C dash, I shall join it with the, so any line coming out of B and C will be hidden line unless it is an outer edge. So lines coming out of B is B to A, B to O, and B to C. So B to A and B to O happen to be outer edges, cannot be hidden line, but B to C definitely not an outer edge, so it is a hidden line. Similarly C dash, so any line coming out of C will be hidden line unless it is an outer edge. So C to O, C to D, and C to B. C to O and C to D are forming outer edge, so they cannot be hidden line, but C to B definitely it is a hidden line, but we have already drawn that. The fourth rule is all the other remaining lines are visible lines. So the rule is D to O are the remaining lines and A to O is the remaining line, right? And finally we have the axis line which I'll be drawing here, O1 dash. So I have O1 dash over here. So let us draw the axis line. So here we have satisfied again the two criteria, that is receiving one of its base edges on HP and the axis is inclined at 45 degrees into HP. Though that axis inclination we have gotten it by this particular formula, minus 90 minus 45, and then we have drawn the base first. Okay. Next, the third criteria is it is inclined at an angle of 45 degrees to HP and to VP at 30 degrees. Again, yes, this is another beta angle problem. So let us draw the beta angle. So for that reason again I will draw a parallel line to the XY line, makes it easier for me to solve. So this time I'll take the line from this side. So we have been doing always this side. From this side I'll take a point here. So the angle of inclination to VP is 30 degrees. So 30 degrees is here. Right? Next, measure the distance from the first position front view, that is O1 dash to O dash. So basically my 60 mm length. So this is my point O. So not my point O, that is from basically from my first position. I'll draw the line through that inclined line. Second position top view I shall come here, O1 dash to O dash. So this is my final O, right? And this becomes my O1. So from here I'll draw the line from O to all the way, I'll extrapolate it backward. So this becomes my beta angle. So according to our figure, the beta angle happens to be 43 degrees, right? So let us locate all the points now. So from O to C I shall measure, and O to B will be the same. So from O to C I shall cut the arc here and here. O1 to C, O1 to C and O1 to B. Next, so basically I have drawn located my C and my point B. Next, O1 to A and O1 to D is the same. So O1 to A, okay, I think it's cutting it little too close to the XY line or the actual reference line. Let us see. I hope it will not cross. Then C to D and B to A is the same. Oh, it is just before that. So thankfully it does not cross. It should not cross. People, please make sure it is not. It should not even be this close also. I think somewhere I've gone a little wrong. Let me just have a look again. See, so I've made a small mistake. Yeah, this is my actual point, right? So basically we have recreated the second position top view and the third position top view, but inclined at an angle of 30 beta. For beta angle procedure we have done, and we have gotten the angle of inclination as 43 degrees. So I have my point A over here, B, C and D. Next, let us draw the projection lines and get the front view now. Okay. Right, so from A dash to A dash bracket D dash I have drawn a projection line. B dash to C dash I have not drawn since it is along the XY line. And yes, from point O also we are supposed to draw the projection line. So this is a real point, so that is why I'll be doing the O dash. Okay, O1 dash I can do that a little later. Okay. So from point A and A dash they are meeting here. So this is my new A dash. B and B dash are meeting here. So this is my new B dash. C and C dash are meeting here. So this is my new C dash. D and D dash are meeting here. So this is my new D dash. Right? So apply the rules again. O dash to C dash. O dash to A dash, A dash to B dash, and B dash to C dash. Again, the next rule is identify the point closest to the XY line. In case of squares, you are supposed to take a single point, pentagon is supposed to take 2 points, and hexagon is supposed to take 3 points. So since there's a square pyramid, we'll be taking the point closest, that is my point D. So any line coming out of D or D dash will be hidden line unless it is an outer edge. So the lines coming out of D dash is D dash to A dash, D dash to C dash, and D dash to O dash. These are the only three lines coming out of D dash. So D dash to C dash, hidden line. D dash to A dash. And D dash to O dash. And the last rule, all the other remaining lines are visible line. That is, the only line left out is B dash to O dash. And let us draw the projection line for O1 and locate the point. O1 dash, and from O1 dash again we have a axis line. So we have completed our projections, right? Thank you for your time.